Hey guys, Buildzoid here, and today we're going to be doing an unboxing video. Not something I really do, not because I haven't tried it on other occasions. Like, every so often I want to get some, like, easy content done, and I'm like, oh, I know, I'll try do an unboxing video, and then it turns into an unmitigated disaster, and I just scrap all of the footage, so, yeah. But hopefully this time that doesn't happen, because, I gotta like recover from this very expensive purchase somehow. So this is of course a ASUS ROG Maximus Z690 Apex, and I went ahead and bought it. It cost 570 quid. And so, you know, big thank you to all the AHOC patrons and people who buy stuff from the AHOC Teespring store, because without you guys, we would not, like, I would not be taking a look at one of these right now. So, yeah, because I did try to get like I did try to ask ASUS if they would be willing to send one over. I never got a response, and so I just kind of decided to buy this because I do believe this is one of the peaks of Z690 motherboards. And so I must have one. Like, this is one of those motherboards that, you know, a couple years in the future, I'd probably be looking for one on eBay to add to my motherboard collection because it's just such a freaking awesome motherboard. Now, admittedly, buying it in a few years from eBay would probably be significantly cheaper than buying it right now, but in a few years, nobody would care. So here we are, the Maximus Z690 Apex. I am honestly kind of sad that it's not called the Maximus 14 Apex. I know the like XIV would be kind of ridiculous, but imagine having in the future a Maximus Z, or you'd have like eventually we'd get to like a Maximus, what is it, XX Apex, right? Or a Maximus IX Apex or XIX Apex. Actually, no, IX we've already had. So you'd have, anyway, Roman numerals are complicated. I give up. But yeah, like, I think in the future having the Maximus 20 being a Maximus XX Apex, I think that would have been kind of cool. But yeah, ASUS decided that they're not doing that. So we just now have Z690 on the box. Anyway, let's open it up. And here is the board in all its glory. Now, I couldn't help myself. I already opened it up once because, you know, like the moment I got this board, I wanted to take a look at it. That's just kind of how I am. But yeah, so we've got this plastic cover on that, which is standard ASUS motherboard packaging. And I gotta say, the ROG here is, okay, for you guys, it actually looks quite horrible. For me, it's not quite so bad, because it's like this weird mirror finish. I'm still putting electrical tape over it now that I say that. Yeah, I'm putting electrical tape over it. It's got this, like, weird, like, mirror finish to it, and I think pixelated anything just looks horrible. It's kind of like how, yeah, I just don't know why you'd want a pixelated anything anywhere. So I'm gonna put electrical tape over that eventually. But let's get let's get the board out of the way and actually take a look at the accessory pack first. Because I'm kind of interested if they included anything noteworthy with this one. Normally I don't bother to take a look, but we do get a M.2 adapter card. So I believe this is a Gen 5. Yes, it is a PCIe Gen 5 M.2 adapter card. This one only takes one M.2 drive, so it's just an X4. Yeah, it's just an X4. It does have, like, this is actually an X8 connector, but they've only, like, you can see that they only wired the X4 part of it. And this is exactly why I'm so confused why you would have on motherboard, like, on a motherboard PCIe Gen 5 M.2 slots, because this is passive, right? Like, this is completely passive. This is literally just traces going from the PCIe slot straight into that M.2 connector. So, really, I see no and the thing is, MSI, so I need to check this, but I know for a fact that at least on the Z690 Unify from MSI, you get X8, X4, X4 support. As in, that second PCIe slot actually splits into two, like, by 4 PCIe links, if you have, like, a dual M.2 SSD card. So, Yeah, that's why I'm so confused why there's motherboards with like dual Gen 5 M.2 slot, like with a Gen 5 M.2 slot on there, when you could just have an adapter card like this with dual Gen 5 slots, and then you would just need to implement the 844 configuration somehow, which does work. Like there's literally a level 1 text video from about the Unify where they run two Optane drives on one of the PCIe slots of that motherboard in 844. So, wait, 844. Yeah, 844. Anyway, so yeah, we get this Gen 5 M.2 card. Not that I'm ever going to use that. Well, actually, who knows? Maybe in 10 years I'll actually have a use for that. You get a USB drive with all of the, I'm assuming, drivers. Well, that's nice, you know, because, yeah, better than a, like, this is actually useful, unlike the usual CD that you get. Though I wonder if they've like reformatted it, because I have like if the drive has a weird format to it, because I have some other USB sticks from other motherboards which actually don't like immediately get recognized as USB sticks, which is kind of annoying. So I hope this is just a dumb USB stick, because that way it's easier to reuse if you don't actually care about the drivers on there. Motherboard manual. I highly recommend that you read the motherboard manual. This, I mean, not after you've bought the board. Like, the cool thing is you can download these online before buying your motherboard, so I highly recommend, like, basically, if you want to check that a motherboard does something that you want in terms of functionality, read this. This'll actually tell you everything the motherboard really does, rather than, like, going through the spec list or something. Anyway, we have postcodes obviously documented in there somewhere, but yeah, it's been a while since I've actually had to read a motherboard manual. We have a warranty information thing. We have quick start guide, so okay, that's useless. We've got a safety information. What's this? Get ready to rock the gaming world with ROG. It's a member of the elite gaming community. It's Armory Crate. Oh boy, the terrible app now has a cringy calling card for it as well. Lovely. The motherboard level, like the motherboard level bloatware has now got a cringy calling card. Oh man, this sticker pack. Oh no, it survived. Not really. Yeah, like I like sticker packs. Also, ASUS has nicer stickers than like I think. Well, definitely than Gigabyte. Like Gigabyte sticker pack is if you've seen it, you know exactly what I'm talking about. Like it's weird. This on the other hand, like yeah, it's a nice sticker pack. I like it. Unfortunately, it did come in folded over, so at least the board has stickers. And then that's the bottom of that part. Okay, so we're just gonna put all of that back there. Let's take a look at the other section of the board. And here we have all of the other accessories. What's in this? What the hell is that? Oh, it's the ROG oscilloscope thingy. And it's all taped up. Wait a minute. It's like I could grab a knife. But there we go. Got the tape. So that's the ROG True Voltician, I think it's called. Yeah, ROG True Voltician. So that's their like mini oscilloscope thing. I wonder how hard it would be for me to get like comparable measurements to this using my own oscilloscope. Yeah, to see like what the difference is between what this measures and like my personal scope does. So yeah, the main issue I can see, well, actually, this probably measures from the op-amp that they have on the board, so I might just be able to hook up to that in parallel, and hopefully that doesn't cause any issues, but yeah, still, like, this is a cool little extra. I'm not sure why they needed to include it in a separate piece of packaging. I mean, the anti-static makes perfect sense, but, like, I'm not sure why they needed the extra little box, because, like, this could have been just sitting there, but whatever. Actually, I'm just not going to bother replacing that. What else do we have? What's this? ROG graphics card holder. Oh. Oh, I guess the ASUS has this too now. Oh, this is magnetic and stuff. That's neat. Okay, so this is like supposed to go at the bottom of your case, and then it can support your graphics card. Not a problem you have to worry about with a horizontal test bench, so I'm never going to have to use that. The dim.2 thing. So this is just a holder for your for more M.2 drives. I don't know why I'm unpacking this. This is another one of those things I'm never going to use. So yeah, actually I'm going to keep the scope dongle out because I am going to be using that. I do want to see how that works. We've got some SATA cables. We've got some temperature sensor? No, RGB extension cables. Front panel front panel thingy. What's this? I guess. Oh, this will probably be for the little accessory cables for the oscilloscope. So that you can hook it up to other things than just the motherboard. Got some clips for M.2 drives. Got screws for M.2 drives. We've got are those fan extensions? Oh no, those are RGB extensions. How boring. Like, if they had, like, a bunch of fan extensions, I think that would have been neat, but oh well. More SATA cables. Temperature probes. What else do we have here? And Wi-Fi antenna, because, yeah, so I think that covers everything except, what's this white thing? Oh, you get a... whatever the hell this is called. I can't remember right now. Yeah, so we're going to close that up. This back. Get rid of the box and take a look at the board. We are not going to be disassembling it right now, just taking a look at it. Which I've already done a lot of that, but it's so much better when it's not just photos of the board. So I can definitely confirm. I mean, I already confirmed this because a friend of mine got his Apex already. So he sent me a picture of the capacitors up close, and yeah, these are 3-terminal aluminum polymer. I'm assuming SP caps. And the reason why I bring that up is because the 3-terminal variant of these it's the best variant. So basically, the whole advantage of having this, well, there's sort of 2 advantages for extreme overclocking. So one, SMD, well, molded polymer capacitors like this, because the thing is, you can technically get the CAN capacitors in an in an SMT package as well. But these, molded polymer capacitors, so because of the physical structure, like the physical shape that they have a much lower ESL and ESR than your regular through-hole capacitors, the usual cylindrical cans. And that gives them a pretty big advantage when it comes to just releasing, like storing and releasing energy based on the needs of the CPU, right? So when the CPU suddenly goes low resistance and tries to pull in a bunch of current, these capacitors will release that energy that the CPU demands much more quickly than if you had your regular through-hole CAN capacitors. But the thing is, so that's already an advantage if you have the regular 2-terminal SMD polymers like this. But there's a 3-terminal variant which adds an extra ground tab. So you get like a voltage, you get a positive, basically you get an extra ground tab, because I keep mixing up the terminology for like anode and whatever. So we're just going to go, so you have a voltage tab, and then you have the ground, and then you have a second, well, normally you'd have voltage and ground on opposite ends, but on these you get a middle tab, which is another ground. And that is there to even further reduce the ESL. And so, yeah, these are basically like super, super fast capacitors is what these are. You can also get them in really, really low ESRs. And I'm really happy that ASUS actually opted for the 2.5 volt version. So MSI has been using this style of capacitor for their high-end motherboards for years now, but they always used like the 4 volt variant. Which is kind of excessive. You really shouldn't need to use more than a 2.5 volt capacitor on like a V-Core power rail. And the thing with the 4 volt variant is that the higher voltage ones, you can't get them in as low ESRs, and you also don't, like, they're not 3-terminal, they're just 2-terminal, but so you also have like an ESR disadvantage if you go with the higher voltage variants, but these are 2.5 volts, 3 terminals. So these could very well be 3 milliohm ESR, which is like the lowest ESR you can get in a polymer capacitor. And then also combined with the 3-terminal packaging, super low ESL. Like, this thing should be an absolute voltage regulation beast as far as motherboards go. Like, this should definitely, like, if I had to guess which motherboard on Z690 has the best transient response, it's this. There's also a pretty decent chance that this is actually pushing well into the limit, like well into the territory of diminishing returns. So there's no measurable difference within like any operate. Like, you could probably find some scenario where these would show up an advantage, maybe during like a thermal throttle event. So fun fact, and I've not checked this, and this is something I do need to check about 12th gen CPUs, but with Intel CPUs, when they change clock ratios, it actually causes a really nasty transient, because basically the whole CPU resets itself when it does that. So it basically, like, you have your CPU running, and then when it needs to go from, say, 5 gigahertz to 4.9 gigahertz, the whole CPU stops. Whatever it's doing just stops, changes ratios, and then goes right back to full load. And this is basically the worst transient you can trigger. It's also triggered every time you have like an AVX down clock, which leads to funny things like, for example, on what you can run into is if you actually use an AVX offset when overclocking, and then you're doing your stress testing, you might find that with an AVX offset, you actually get worse stability than without the AVX offset. And the reason that happens is because when the CPU changes clock ratios based on the offset, it basically crashes itself. And just the voltage regulation, well, like, it crashes itself because it causes the voltage regulation to go completely out of whack. So in that kind of scenario, these caps might actually measurably improve things because, yeah, they're just, they should be just so much better than whatever you can find on any other motherboard. So I'm really, really excited about those. The other advantage that these have is that because they're low profile, for extreme overclockers, you can mount some really excessive LN2 pots, like absolute monstrosities that, you know, basically fit just between the inductors that are around the socket and would otherwise like collide with regular CAN capacitors. So that's another advantage to these SMD 3-terminal polymers. So yeah, I'm super excited that ASUS has finally started using these because these are awesome. Very expensive also. They are like way more expensive than their through-hole counterparts. But like, to a degree, like, when I was told how much more expensive these are, because the thing is, if you look at like third-party suppliers for capacitors, these don't actually look that much more insanely expensive than your regular through-hole capacitors. But it turns out you can get some really deep discounts on the regular through-hole parts if you're like a very large volume manufacturer. If you aren't, but even if you are, you know, buying huge quantities of capacitors, these are still insanely expensive. You can't get as deep discounts for these as you can get for the through-hole parts. So, those are, like, I'm really excited to see them, but they are not cheap, which is why you don't see them on the vast majority of motherboards. Other than that, yeah, we've obviously got just the 1 DIMM per channel memory configuration, DIMM.2 slot for your extra M.2 drives. The board does have dual X8 PCIe support, which I'm pretty excited about. It should... So I've already heard from somebody else that they managed to get, like, old multi-GPUs running. So there's a decent chance I'll be able to run, like, quad crossfire on this board, which is pretty exciting for me. Other than that, we've obviously got power button, reset button. Then we've got some switches down here. Okay, so we have RSVD VLATch switch. That's fun. Oh, I'll need to mess with that because this is the first motherboard I have with the VLATch function. I believe this is the BIOS switch. Then we have BCLK up-down buttons, which I'm super excited about. Like, these are so helpful for, like, pushing max memory frequency. Then we've got more switches, which I don't know yet. Voltage read points that aren't just solder bumps. This... Like, I'm so excited about these. So these are actually like plated through holes. So when you... Do I have a multimeter on hand right now? I don't. But basically the advantage to this compared to like solder bumps, which is what a lot of other motherboards will do, is that your probes won't slip off of these, right? Like, because they're holes. So you can just put the probe in them and the probe will stay, and you don't have to like worry about the probe sliding off of a solder bump or something like that. They've also made the post code absolutely gigantic, which I'm a big fan of. Like, it's a little thing, it's a minor thing, right? Like, it's a bigger post code, but it's just like the thing I like about that is just like Motherboard's so overclocking focused that the post code got bigger, right? So I love to see that. I absolutely love to see the giant post code. What else do we have? We have some troubleshooting LEDs above the post code, which I'm not sure what all of those are just yet. We'll find that out eventually. Next to that, we have a button over here. I'm assuming that's probably safe boot. What else do we have? I have some white fan headers. I wonder if those are full speed fan headers or if that's... Like, I think this one's definitely full speed. This is the water flow fan header, and that one should be full speed. And I like having motherboards where they get rid... Oh, they got rid of that. So ASUS used to have a feature on some of their overclocking boards where you had a switch that would put all the fan headers to full speed. I'm guessing we just now have a couple of permanent full speed fan headers. Or at least I'm hoping that that's the case, that like the white ones are full speed. Or maybe they're like high current. Because the thing is, if you're on a test bench, you don't actually care about how much noise the system makes, and you just want the fans at full speed, so it's just kind of like saves me the time and effort, you know? Just plug everything into the full speed headers, which is what I actually do with my other Apex boards, or at least I run them with the full speed fan mode permanently turned on the boards where that is an option. Yeah, and then I guess let's flip the board over, because... I've not seen many images of the back of the board just yet, but yeah, here we go. Well, actually, I've seen images, but I've not seen many on the internet. Oh man, they've got a lot of ceramic in the memory section. I'm really surprised they did that. Like, I am really surprised that this is a thing. Also, we have a bunch of... actually, those are probably high voltage, aren't they? Yeah, those are 56 microfarads, so those are going to be the 16 volts. So, yeah, but also the entire input filter is made up of SMD aluminum polymers. Now, these are just 2 terminals, which is completely fine, because the input filtering side of the VRM really doesn't need the same super low ESL that you need on the output. You also don't need as low an ESR. But I'm still surprised that they went for these... Because honestly, like, I was looking around to buy some of these recently, and they were discontinued. At least on DigiKey, they were discontinued. Though I didn't try any other manufacturers. We've also got some kind of suspicious MOSFETs hanging out around the power delivery section. I wonder what those are for. I wonder if those are voltage clamps. Because ASUS has done that on some of their motherboards in the past, where they'd have MOSFETs that would basically... If the output voltage of the VRM ever got too high, those would basically turn on, and the idea was that all of the... Like, these would basically just short the VRM to ground, so the MOSFET would get absolutely destroyed in that kind of event, but it would ideally prevent the CPU from dying. So that's kind of the idea behind that. I'm not sure if that's what these are, but that is a thing that ASUS has had in the past. It's kind of a neat idea. I don't know if it actually worked that well. I don't think it did, because if I remember correctly, these trigger at like 2 volts or something, which is like if your voltage gets that high, it's a bit too late. But yeah, I'm not sure. Maybe they're for something else, and if they are for something else, then hopefully whatever they do is going to be more useful. Oh yeah, here we have our BGA PCIe Gen 5 switches for the dual X8 support. Obviously SMT. Oh man, they've done everything SMT for the... Like, we've got the SMT Gen 5 slots, but they've even done SMT for the regular Gen 4 slot at the very bottom. So that's really excessive of them to do that. Anyway, yeah, the socket itself is actually relatively empty, but there's a very good reason for that. The thing is, if you have such if the thing is, so capacitors on the back of the board are less effective than capacitors on the front of the board, because vias, which is how you connect things vertically through a motherboard, have kind of a lot of like resistance and inductance to them. And so if you have a lot of very, very fast capacitors on the top side of the motherboard, there's not really much point having a bunch of ceramics on the back of the board, potentially. So I'm assuming that's why they ditched these, is just because the filtering on the top side of the motherboard is so effective that filling the back of the socket just doesn't matter anymore and doesn't make a difference. Though we do still have one of those 3-terminal polymers hanging out over here, but I think that's for the iGPU. I think that's for the iGPU. Does this even have an iGPU output? It does not have an iGPU output. But do we have an iGPU power rail? It doesn't look like we do. Okay, so maybe that one's just for vCore. Either way, like I'm not too like the socket here is basically telling me that the top side of the board is doing all of the work, and that's a good sign. So this right here is not like this is, to me, this isn't like with some of the MSI motherboards where it's like that socket is suspiciously empty, though funnily enough those boards still had perfectly good transient response in testing. So yeah, like this kind of stuff is hard to judge at a glance, but yeah, like the combination of the 3-terminal polymers on the front, and then like the socket being like with the 3-terminal polymers on the front, like the socket being empty is just kind of like, yeah, whatever. Evidently they really like those polymers are just so good that this isn't even necessary anymore. These are interesting though. These I'm pretty sure are just for the memory, and that's just. Yeah, that's interesting that they would have those multi-layer ceramics there for the memory, and then they have, these as well. So, yeah, that's a really unique, because normally right in this area you would see through-hole capacitors. But they've evidently, and I suspect these are 47 microfarad multi-layer ceramics, which is a very high capacitance for a 0805 multi-layer ceramic capacitor. But yeah, it looks like they've just replaced those with ceramic, which is kind of neat. That could be somewhat beneficial. Obviously, the memory is also handled by 3-terminal polymers. I mean, hey, you're already buying a bunch of them for the vCore. Why not, why not use more of them for the memory power? Also, the VRM on this board is a full wraparound, like is a full U shape around the CPU socket, right? So I imagine the power plane internally, not on the top layer. You can see we have a bunch of traces running through this area. So obviously on the top layer, we don't have like one big power plane everywhere, but internally, and this is an 8-layer PCB as far as I know. So internally, there's probably a very, like, you basically have a rectangle under the socket, which is just vCore, which should be beneficial for power delivery, right? Because with power planes, you basically want the power plane to be as like wide relative to what it's powering as possible. And there's really not much better you can do than just like wrap the completely wrap the power delivery around the thing you're powering. So this is a really cool idea. Now they've also kind of done it because they ended up putting 24 power stages on the board, which honestly I am. Like, they could have done the wraparound with half as many power stages, and I would have still been equally excited about it. But, hey, I'm not going to complain. Like, I'm paying $700 for the board, so I'm not going to... Well, the board is $700. I actually paid more than that, because 570 quid, I think, is like $770, something like that. Might even be $800. So I paid a lot for this motherboard. So I'm not going to complain about the fact that they gave me more power stages. I like having more power stages. I don't think they're going to well, the main thing is I can run the motherboard naked. So maybe I won't even bother putting electrical tape over this. I'll just run the board with no heat sinks. Well, obviously you do still, I'm not sure that Z690 runs that hot, but I wouldn't be taking off the chipset heatsink. So yeah, this board is just like this is the peak of the Apex motherboards as far as I'm concerned, right? Like it's the first one, like, and I'm so excited that like ASUS made they went from using literally through-hole capacitors, which is about as standard as it gets for all of the past Apexes. Like this is the first Apex where they've gone ahead and switched over to like a significantly better bulk capacitor. And like they went all the way. They didn't go from like, oh, through holes to like 2-terminal caps or tantalums or something. No. This is like we went from through holes to straight to 3-terminal, like what looks to be SP caps. So I'm pretty excited about that. We've also got this rubber thing on the... Is that... Oh, that just comes off. Okay. Because that doesn't actually feel very nice to touch. And then we've got the socket itself, which obviously is just loaded with multi-layer ceramics, which makes perfect sense. It is worth noting that on the past motherboards from ASUS, where you'd only get like the regular through-hole capacitors, they did still have like a bunch of multi-layer ceramics, extra multi-layer ceramics mixed onto the front of the board. So, you know, ASUS has always done relatively, like, somewhat more elaborate filtering configurations for their motherboards than the absolute bare minimum, but this is, like, well into the territory of, like, high-end GPU power delivery. And I'm really excited about that. Like, this, yeah, like, I am super excited. We even have the, like, crazy wraparound VRM, which there is a GPU that does that. It's called the Radeon 7. That also has a full-on U-shape wraparound VRM. For the same reason, it's just like you can have a much bigger power plane if the power comes in from all of the angles instead of just one of the angles, right? Yeah, man, this board, I think it's pretty clear why I bought it, right? Yeah, and then even the rear I/O, like if it weren't for the fact that like I just plan to use this as a test bench motherboard, this would be a totally excessive but extremely nice daily motherboard in my opinion. Right, 9 USB ports and PS2 ports and the clear CMOS and the BIOS flashback and the Wi-Fi 6E that I'm never going to use. Just 2.5 gig LAN, which admittedly there's other motherboards at lower price points that if you care about more advanced networking, yeah, you can get that on some cheaper boards out there, but I don't care about more advanced networking. I want USB ports, and I want crazy power delivery, and I also want less DIMM slots, and this board just does all of that, and then also the postcode is huge, which, like, I know, like, it's awesome. It's literally, like, yeah, this is, like I said, one of the peaks of Z690 motherboard design. And I say one of the peaks because I'm not 100% certain that this will be absolutely my, you know, favorite Z690 motherboard to use. Gigabyte is sending a Tachyon, and I really, like, I'm hoping to talk MSI into sending over a Unify X. So we could do a comparison between all of those. Actually, wait, can I not? Wait, is that locked right now? Oh, that's not locked right now. That is not great. The little... Yeah, okay, you know what? I think that's still a stupid gimmick. Because the whole reason this exists is because of stupid, like, heat sinks like this, right? Like, this right here, if this didn't exist, you could get at this. Oh, well, there's no downside to it. It's just kind of like, that seems kind of silly, but, yeah, it's neat. It does what it's meant for well, so... yeah, and I can't imagine that it would break, but I normally, like, straight up just remove the PCIe locks on my motherboards. That I, like, on motherboards that I use a lot, I just remove these because, yeah, I don't like dealing with those. Yeah, so that is the Z690 Apex. An absolute, like, beast of a motherboard. I am so, like, I'm annoyed that like, the problem is, like, I spent so much money on this motherboard that now it's like, oh, I'm not gonna be, so for, like, for LGA 1200, I have a 10700K modified so that I can get oscilloscope measurements that are consistent across all motherboards, because they're taken from the CPU, and so, like, they're always taken at the same location. But for 12th gen, like, I can't really do that for, like, at least 3 months, or something like that. Well, actually, no, maybe I could get a probe. Well, no, because, 3 months was kind of correct, because, like, December, I'm going to be traveling, and so there's no way I'm really getting anything that advanced done during December. But, yeah, so I'm kind of annoyed that I don't have a way to check, like, I'm not going to have a way to measure the performance of the capacitor configuration here for a while, but man, this is just like, and honestly, I really wouldn't be surprised if this crazy capacitor configuration ultimately didn't really, you know, even register in measurements or in terms of overclocking performance, because there is a limit, right? And I do think the LGA 1700 socket is actually better than the old sockets. I suspect there's more pins dedicated to power delivery. At the same time, the CPUs just kind of pull less power as well, so that might be part of it. So you might not actually have any more pins for power delivery. It might just be a case of like the power, you need less power, and so the socket is, less of a bottleneck in that kind of scenario. But yeah, I'm super excited to have this board. Because yeah, unfortunately you're not going to see it in action for a little bit because I do need to, like I have other motherboards that I need to test first. And since I bought this, it's not like this is the funny thing is like since I bought this, I won't piss off ASUS by not using it for like a month. I don't want to do that, obviously. I want to use it as soon as possible, but I do need to make content with some of the other hardware I have first. So if you're hoping for videos with this motherboard anytime, like this motherboard actually running anytime soon, yeah, those are kind of in the future. Yeah, and I think I'll do the PCB breakdown after I actually run this board. Because I mostly want to figure out the memory over, like, really the only thing I'm wondering about is the memory overclocking behavior, which is going to be fun because I have Gigabyte Hynix memory sticks. So I'm going to be running Gigabyte RAM on an ASUS motherboard. Not that the memory sticks should, like, it shouldn't matter. It's just kind of funny to, Gigabyte RAM on an ASUS motherboard. Anyway, that is actually it for the video now. So, yeah, I have a Z690 Apex, and it's all thanks to you guys all thanks to you guys. So, again, huge thank you to the patrons and the people who buy AHOC merch on Teespring, because without you guys, I wouldn't be able to, put my incompetent hands all over this absolutely incredible motherboard. Yeah, I can't wait to like start using it. So yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below if you'd like to support what I do here with actually hardcore overclocking. I do have that Patreon, and there's also the AHOC Teespring store, where you can pick up shirts, stickers, posters, hoodies, the usual YouTuber merch. Actually, speaking of hoodies, I'm currently wearing it. There we go. There's more on the back of it. It's a zipper hoodie, so the printing space on the front is very limited, but yeah, so there's zipper hoodies now on the AHOC Teespring, so if you'd like to support the channel, it'd be much appreciated if, you checked out the Patreon or Teespring. And that's it for the video, so thank you for watching, and goodbye.